Okay, 8.1. 8.1 was pretty large, so I split it into 2 different days. A lot of what we do today, hopefully, is just review. We'll see. Okay, 8.1a. So here we're just going to fill out the table, plug in -4 for x. The notation is, so g of x equals 5x minus 2. That means we're looking at a function whose name is g, and it's written in the variable x. If you wanted to graph this, you would just replace the name of the function with y. So essentially, those two are the same thing. One is in function notation, and one is just in y equals notation. So if I wanted g of -4, all that's saying is rewrite the equation, and instead of using x's, use -4. So that would be 5 times -4 minus 2. So 5 times -4 is -20 minus 2 is -22. So g of -4 is -22. Okay? And the numbers that we plug in here are called the domain. So these are domains. And the numbers that come out are called the range. So domains go in and ranges go out, come out. Okay. So here I have a function L of d equals 51 plus d. What is the length of the road after 22 days? So this says the length of the road is 51 feet plus, or 51 plus 22 days. So 51 plus 22 is going to be 73 miles. Okay. So here we have a function b of x is equal to 45.25 minus 0.8 times x. So this is how much money he's going to have left. He starts with $45.25 on a gift card. Who does that? Right? You get a gift card for your birthday. How much is on it? $45.25. And he wants to buy pictures that cost 8 cents each to print. So 45.25 minus 0.08 times 20 prints. So 45.25 times 0.08 times 20, and helps if you subtract it instead of multiply it. And we get 43.65. Easy enough. Okay. So here is another description of domain and range. Okay. So it wants to know what numbers go into this function and what numbers come out. But in this case, we weren't given an equation. We are just given a set of ordered pairs, a set of x's and a set of y's. So if I wrote all x's and I called this my domain, that would be the numbers 7, 5, -9, and 6. And all of my y's are going to be in range, and -3, 0, 5, and 6. So G is the relationship between my domain and my range. So G says person number 7 is given negative $3. Person number 5 is given $0. Person negative 9 is given $5, and person 6 is given $6. So the X's are the domains, in this case, people. The Y's are the range, in this case, money. And G is the relationship connecting the people to the dollar value. That's what the function does. Okay? So we need set notation. Whenever our answer includes a list of numbers, we use these funny set brackets. And then we would list for the domain, I would do 7, 5, negative 9, 6, and then close it with the funny brackets. And the range, same brackets, is going to be negative 3, 0, 5, and 6, all separated with commas. That's it. Okay. So interval notation. So it says graph the set of all x's such that x is between negative 7 and 5, but it's not equal to 7 and it is equal to 5. So what sort of circle am I going to put at negative 7? Open circle or closed circle? Open. It's not equal to. So not equal to gives me an open circle. And then 5 is a closed circle. And then I'm going to graph everything in between. Okay? But inequality notation is sort of a middle school thing. You're big boys and girls now. We're not going to do that much anymore. Instead, we're going to use interval notation, which is much slicker. It's much quicker. So in interval notation, what we do is bracket low number, comma, high number, bracket. However, we have the option between brackets or parentheses. And over here we have the choice between parentheses or brackets. These are not equal to, and these are equal to. So to do this same set using interval notation, my left side is a parenthesis, my low number is negative 7, and then my right side is a 5, and because it's a closed circle, I use a bracket. Okay. Now, there is one little trick here. What if I had 7, 8? What does that mean? Well, it could mean two different things. It could mean the point 7, 8. Right? It could also mean every x from 7 to 8. So how do I know the difference? How do I know if it's a point or if it's an interval? Well, if it's an interval, it needs to say either x equals or it could say y equals. Right? If it's a point, we usually use capital letters, like point A is 7, 8. Okay? So if it says x equals or y equals, that means a set of numbers. If it has capital A, capital B, capital P, then that would be a point. Okay? But what if my graph was x is greater than negative 2. Nope, let's do equal to. Greater than or equal to negative 2. How do we put that in interval notation? Well, it's a closed circle at 2, and then the arrow goes to the right. Okay? So in interval notation, what is the low number? Negative 2. Does it get a parentheses or a bracket? Is it equal to? Yes. So it gets a bracket. We should probably put x equals. And then what is the right side number? There isn't one. So what is the farthest possible number to the right? Infinity. Can the graph ever actually equal infinity? No. So infinity always gets a parenthesis. Okay? And if it went the other direction, let's say it looked like this, my low number would be negative infinity, and my high number would be 3. So that would be the interval from negative infinity to 3. All right. What is the domain of this function? Well, if I list out all of the points, negative 3, comma 3, 2, comma negative 1, 3, 0, and 4, 4, my domain is going to be negative 3, 2, 3, and 4, all of my x values. And the range is just going to be 3, negative 1, 0, and 4. And that's it. Get to work.